Welcome to the course, Your Foundation for Machine Learning and Data Science, section Object-Oriented Programming, OOPS Overview. In this section, we will review the basic concepts in object-oriented programming. OOPS is a programming paradigm that uses objects and classes in programming. The main concept of OOPS is to bind the data and functions to work together as a single unit so that other parts of the code can reuse them without redundancy. The terminologies used in object-oriented programming are object, class, method, inheritance, polymorphism, encapsulation, and data abstraction. Let's see each one of them in detail. Let me try to explain objects, classes, and methods with an illustration. Let's say we have a data set like this. The first attribute empid is called identity. The rest of the attributes that describe this identity are called state. Each row of data is called an object. Let's say we add a few more rows, delete a row, and modify some of the attributes. The actions such as add, delete, and modify are called methods. Class is equal to attributes plus methods. In other words, an object is an instance of a class. Let's see the formal definitions of an object, class, and method. What's an object? An object is an entity that has an identity, state, and behavior associated with it. Identity gives a unique name to an object and enables one object to interact with other objects. State, represented by the attributes of an object that reflects the properties of the object. Behavior, represented by the methods, that is, actions or operations of an object that reflects the response of an object. For example, an employee is an object. Employee ID is the identity. Employee name, date of birth, age, salary, joining date, designation, etc. are state. Add an employee, delete an employee, and modify employee details, etc. are behavior. In Python, everything is an object. Integers, floating point numbers, strings, arrays, matrices, lists, dictionaries, etc. are all objects. Any single integer, example number 5, is an object, and any single string, example hello world, is an object. Objects can contain other objects as well. Example, arrays, matrices, lists, tuples, sets, dictionaries, etc. What is a class? A class is a logical entity that contains the blueprints of objects, defining the common attributes called state and behaviors called methods from which the objects are created. An object is an instance of a class, and objects have the behavior of their class. What is a method? A method is an action or operation which an object is able to perform. Let's see what an inheritance is. Inheritance is a mechanism in which one class acquires the properties of another class. Let's understand this from different types of inheritance. There are 4 types of inheritance, and they are single inheritance, that is one-to-one, multi-level inheritance, that is nested one-to-one, hierarchical inheritance, that is one-to-many, and multiple inheritance, that is many-to-one. How does single inheritance work? Let's assume we have 2 classes, class A and class B. If we derive class B from class A, that is defining class B using class A, it is called single inheritance. For example, we have a class called doctor, and we derive class surgeon from doctor. Now, the surgeon will have all the properties of the doctor. In addition to the properties of the doctor, the surgeon can also have additional properties if defined. How does multi-level inheritance work? Let's assume we have three classes, class A, class B, and class C. Class C is derived from class B and class B is derived from class A. Here, class B will have the properties of class A and class C will have the properties of both class A and class B. For example, we have three classes, doctor, surgeon, and plastic surgeon. Plastic surgeon is derived from surgeon and surgeon is derived from doctor. So, the surgeon will have all the properties of the doctor and the plastic surgeon will have all the properties of both the surgeon and the doctor. How does hierarchical inheritance work? Let's assume we have four classes, class A, class B, class C, and class D. The classes class B, class C, and class D are all derived from class A. Here, the classes class B, class C, and class D will have the properties of class A. For example, we have four classes, doctor, pediatrician, cardiologist, and neurologist. The pediatrician, cardiologist, and neurologist are all derived from doctor. So the pediatrician, cardiologist, and neurologist, all three will have the properties of the doctor. How does multiple inheritance work? Let's assume we have three classes, class A, class B, and class C. Class C is derived from both class A and class B. Here, class C will have the properties of both class A and class B. For example, we have three classes, cardiologist, surgeon, and cardiothoracic surgeon. The cardiothoracic surgeon is derived from cardiologist and surgeon. So, the cardiothoracic surgeon will have all the properties of the cardiologist and the surgeon. Let's summarize the different types of inheritance. Inheritance is a mechanism in which one class acquires the properties of another class. For example, a child inherits the traits of his or her parents. With inheritance, we can reuse the attributes and methods of an existing class. The new class is called the child or derived class, and the one from which it is derived is called the parent or base class. Types of inheritance. Single inheritance, that is one-to-one, enables a child class to inherit characteristics from a single parent class. Multi-level inheritance, that is nested one-to-one, enables a child class to inherit properties from an immediate parent class, which in turn inherits properties from its parent class. Hierarchical inheritance, that is one-to-many, enables more than one child class to inherit properties from a parent class. Multiple inheritance, that is many-to-one, enables one derived class to inherit properties from more than one base class. Let's see what polymorphism is. Polymorphism is a property of an object which allows it to take multiple forms. Let's consider the example of an operating system. The operating system can be Windows or Mac OS or Linux. All these operating systems have the same purpose but in different forms. Let's see a couple of examples from Python. Example 1. The plus operator. In this piece of code, we have defined two integer variables a and b, one float variable c, and two string variables d and e. We can perform the addition operation using the plus operator on variables of different types. The plus operator adds two integers, adds an integer and a float, and concatenates two strings. Here, The same operator takes multiple forms depending on the types of variables. This is evident from the output it generates. Example 2. The len, that is length function. In this piece of code, we are using the same length function to find 1. The number of characters in a string, that is the length of a string. 2. The number of items in a list, that is the length of a list. 3. The number of items in a dictionary, that is the length of a dictionary. This is evident from the output it generates. Let's see what encapsulation is. Encapsulation is a mechanism to wrap the variables, that is data, and methods, that is behaviors, together as a single unit. It is the process of hiding the information and protecting the data and the behavior of the object. To prevent accidental change, an object's variable can only be changed by an object's method. Here is the pictorial representation of encapsulation. Let's see what data abstraction is. Data abstraction is selecting only the essential data from a large pool, showing only the relevant details of the object and hiding unnecessary details. It helps in reducing programming complexity and efforts. Here is an example. In the master dataset, we have 11 attributes. We have created a view from this master dataset called the telecom customer dataset with only 6 attributes, hiding the remaining 5 attributes that are not required for the telecom customer dataset and preventing any accidental changes to them. I hope now you have a basic understanding of what's an object, what's a class, what's a method, what is inheritance and its types, single inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. Then what is polymorphism, what is encapsulation, and finally, what is data abstraction. With this, I'll conclude this video and I'll see you in my next video, Important Libraries Overview.